So welcome to this week's webinar. Today we're going to be talking about simulation with Optimus, and so right now, I guess before we dive into the content, we're just going to give some things by way of introduction here. First off, everyone that's plugged into the webinar, you'll notice that no one can speak to each other, or you can't speak. You're basically all muted. All the attendees are. And the way this is going to happen is currently all the attendees are muted, so that way you don't have people talking over each other. And if you have a question, there's a questions pane in the GoToMeeting webinar panel on the right-hand side. You may have to expand it by clicking on the red arrow, but you can type your questions in there, and as the webinar goes on, you can keep typing questions in, and at the end of the webinar, we have a dedicated slot for questions and answers, and I can start taking and addressing the questions at the time. Okay, and so we're going to go ahead and get started. And the way this is going to go about is, first off, I'm going to go about presenting and talking about Optimus using a PowerPoint. So I'll highlight some of the features and capabilities in Optimus that are of interest and relevance. And then after that, we'll go into a live use case where I show a live example of a project we used Optimus on. And then finally, we'll go into to a Q&A session at the end of that. Okay, so just a quick intro about us. Boundary Systems is a technology leader in its field of product development consulting. We consult in everything from product lifecycle and data management to simulation and CAD design and consulting as well. And in this particular application here, we're looking primarily at simulation, although this could also reach into other areas as well of product development. And again, we've received many awards in our field and have helped many of our customers, achieve bigger and better levels of success. And this is our main partner that makes, or that's the brain behind Optimus, called NOESIS Solutions. And they've been doing this for many years now. Basically, they play primarily in the field of process integration, and also optimizations, and they have many licenses with many different companies, and you can sort of see by that visual there are three primary verticals. That you have the automotive industry in the sort of the top row of companies, and then you have the aerospace industry, and then finally you have the electronics industry as well, where Optimus can be used in cases where you're controlling PID controllers and things like that. Okay, so in diving into this webinar, we have there was a particular design challenge that we had to overcome, and we used Optimus in this live case study here. So we're going to talk about this and see how Optimus was able to help out with it. Now, this particular design problem is a nose wheel steering arm for an aircraft nose wheel. And we had some design parameters. We knew the material had to be steel. We knew what the load was. And we also know that since this is going on an aircraft, it has to be as light as possible. And now not only that, but we're also restricted to using Creo Parametric, or some people know it as Pro Engineer, as our CAD tool. And just like many other simulation workflows as well, you have a preprocessor that generates the mesh. In this case, we use the GMesh, and then a solver that then calculates or analyzes the results on that mesh. And in this case, we used Elmer to solve the FEA in this case. Okay. Now, what I just described, using multiple different softwares to run different things, that's not uncommon for any simulation process. Typically, you have a simulation engineer that generates the geometry in one software, and then you have to save it out because another software is going to read it in from a certain location. And then when that's done, you have to then save it out because the solver is then going to start analyzing those mesh files. All of that entire workflow that sometimes one engineer controls, and sometimes it goes across multiple engineers because one person is responsible for the CAD design and another person is responsible for the simulation aspect of things. All of that process can be captured in one very simple and easy to use workflow in Optimus. And so this first feature of Optimus here is a process optimization where you can basically tell Optimus, what are the different commands that you want to run, what are the different softwares you want to control, and also what are the different files that are associated with that. And then Optimus does the heavy lifting. Optimus does all of the file copying. Optimus is the one that knows when one software is done, and then it kicks off another simulation. And so because everything is automated, that makes it very repeatable, and you can save tons and tons of time by having Optimus automatically run the simulations for you instead of having an engineer sit there and manually crank out these simulations. And so with the process optimization module, it's not only is it very easy to use, it's literally like connecting the dots, but you also save a lot of time because now you're no longer sitting there controlling 100 simulations or however many simulations you're running. Optimus is doing the heavy lifting and the file copying and all of that behind the scenes. Now another huge feature of this as well is when it comes to improved asset utilization. And now a lot of companies we know, you spend tens of thousands of dollars on your simulation licenses, and you also spend similar amounts of money buying huge machines with processing power that can crank out those simulations, right? Well, on weekends or in the evenings when you don't have an engineer sitting in front of a computer, those licenses and those machines that you've already paid for are essentially doing nothing. And so why not have an Optimus workflow that's already created and can run on its own, and you can then have Optimus run 10 or 20 or 50 simulations on a weekend. So you're still maximizing your computing resources, you're still maximizing your simulation licenses, and your engineers can come back and instead of waiting on simulations to solve, they have quality results that they can start analyzing. The other thing about the process optimization feature is that this feature is designed so that it can integrate with basically any simulation software that you have. In this particular case, we use Creo and GMesh and Elmer, but as you can see from just a small subsection of the icons at the bottom there, it can work well with ANSYS, Adams, LS-DYNA, ANSA, MathCAD, MATLAB, virtually any CAD or simulation or analysis software that you want. Optimus, has the integration to to speak to that software and to push it to control the software and also to receive information from it. Now, the next the next feature of Optimus we'll talk about and highlight is the design of experiments. Now, in Optimus, or I guess not in Optimus, first off, in your typical design or simulation process, one of the key things that usually will happen is you start off with a particular design, and if that meets your desired target, if that meets your allowable stress, you accept that and you continue. But rarely do you see that. Usually, it doesn't meet your allowable stress, or it's too heavy for you to use, and so you then go back and change your dimension, and then you mesh the new model again, and then you solve it again, and then you see what the resulting mass or stress is. And if that still is not within your allowable, then you go back and change the dimension again, and you repeat that process over and over and over again, right? Well, by the time you've changed that dimension 8 times, you've probably forgotten what the first or second result was that you got, right? And so what the Optimus design of experiments feature does is it intelligently chooses design variables for you automatically. And not only that, but it keeps a record of all of these things so that you can begin to use statistical tools to observe different data trends in your model. And so it allows you to very quickly identify your key design parameters, and hence it saves you a lot of time because you're not just sitting there, controlling simulations and hoping you guess the dimensions right. So for example, in that screenshot over there, you'll notice, in that screenshot over there, you'll notice that in the vertical red column, one of the things we're interested in is the stress, and Optimus tells us here in this case that this rib 1 over here, which we're pointing to over here with the red arrow, that rib on a scale from 0 to 1 has a fairly insignificant impact on the stress. So it doesn't really affect the stress that much. But when we look at the mass, for example, because again, we're concerned about making this lightweight, that rib over here plays a moderately significant impact on the mass. On a scale of 0 to 1, that's about 0.4. Whereas the gap over here at the bottom, gap 1, which is again that tiny gap you notice over here, plays a very, very significant impact on the mass. And so basically, the bigger that gap, the smaller the mass becomes. That's why it's a negative 0.9. And so you'll see on the right-hand side over there, the other screenshot was the Inspire optimized, the Optimus optimized model, where Optimus realized from the data trend, okay, I think changing this gap and also tweaking that rib, are the two things you need to do to get the biggest bang for your buck. And you can very clearly and easily see that, with numbers in this case, which, engineers love numbers. And so again, key things about the design of experiments module, it helps you make smarter design decisions. And so again, improving your product quality while saving you lots and lots of time, because Optimus can do all the calculations in the background and then present all of that data to you. All right, the next feature we'll talk about with Optimus here is the design space intelligence feature. Now, what do you mean by design space intelligence? Well, this is typically a case where you have all of those different parameters or variables that we wanted to change, or input, or dimensions, and we have certain objectives we want. So we want to see what the response is on the stress and also the mass as well. Well, what the design space intelligence does is, after running a statistically significant number of simulations, it may be 5, it may be 10, it may be 20, Optimus can then begin to see a trend between all of your design inputs, all of your dimensions, the thickness of your rib, for example, or the dimension of the gap that we just looked at, and your resulting mass or your resulting stress. And it can capture all of that with a mathematical equation that is very simple and concise. And so, for example, in this case here, you're looking at a 3D plot of a mathematical equation where anywhere on that 3D surface, you can give Optimus any 2 dimensions and it'll tell you what the resulting stress is. Now, that 3D surface is created by a mathematical equation, and the benefit to that now is twofold. Number one, you can cut your design time infinitely because it takes Optimus half a second to query a mathematical equation. And so basically what you're looking at here is Optimus is saying, after running a small statistically significant sample set, you can give me any variable and I can tell you what your resulting stress is. Not because I went back and reran a simulation, but I just plugged in numbers into a math equation. And so now, instead of waiting on for this particular workflow we have, ran for about 12 minutes. Instead of waiting on 12 minutes, I can type in new values into that design space and it'll tell me a response in less than half a second. Again, saving you incredible amounts of time. Now, the other benefit you have to this is you can share the model across design teams. And so with Optimus, there's a way to basically make this particular design space model available to other departments. And so say for example, we have a design team that does not have access to simulation software. They don't have the knowledge for simulation software, um, but they want to have a quick way to guess or to check. If I'm in the business of making it, this particular lever every day, if I have this particular dimension for my rib and this dimension for my gap, what is my resulting stress going to be? What can I expect the stress to be without having to run an FEA simulation? Right? Well, instead of them having to send that job over to the simulation department and taking, a few days of simulation time, they can very quickly type in those numbers into a spreadsheet, and Optimus runs the calculation on the math equation and shows them the result. And so all of a sudden, you're dramatically increasing or I guess decreasing your simulation time, because now your designers no longer need to, run a simulation. Optimus can plug it into a math equation. But not only that, you're also keeping your engineering IP and knowledge in-house. And so there's no need to, send this to a third-party company to simulate. You're creating an Optimus model and keeping that in-house, and hence you're leveraging your in-house IP and you're not exposing yourself. Next feature we'll talk about with Optimus here is the robustness and reliability optimization feature. Now, first off, Optimus has an optimization module that you can use to optimize any sets of parameters that you have to a particular objective. So if in this case part of the main goal was to minimize the mass, and so we're going to optimize for that. And now you think, okay, well, other simulation softwares have optimization features as well. Well, there are two differences with Optimus. It's that the first case, other simulation softwares will have one, at the most, two simulation or optimization algorithms. Optimus, in this case, comes prepackaged with about 10 to 15 different simulation algorithms to run an optimization. And so what that means is you're not just using a one-size-fits-all algorithm for any problem you come across, but now Optimus gives your engineers the flexibility of using a different simulation algorithm for a particular problem, depending on what that challenge entails. And now, not only do you have that as well, but with Optimus you also have the robustness optimization as well, which is basically where you can also input in there some sort of real-life variability, right? Because we know that whenever we have a model and we say we want to make a rod, and that rod is going to have a diameter of 1 inch. If we make 1,000 rods that are 1 inch off a lathe, not all 1,000 will be 1 inch. Some will be, 1.01 inches. Some will be 0.99 inches, but not all 1,000 will be exactly 1 inch. And so, how do you then capture that manufacturing variability to ensure that, a 0.99, diameter rod isn't going to send my product into failure? Well, with Optimus, you can tell it what your expected variability is. And so, for example, in this graph over here, the gray point is our mathematically best or optimal design point. But with some manufacturing variability, when we look over on the left-hand side over here, this gray bell is going to be the performance variability. And we realize, okay, some of our widgets will fall in our failure domain if we use the mathematically optimal solution. And so now we can tell Optimus, hey, we know what our variability is. Find us an optimal solution, taking into account our variability, and make sure that we have less failures over a significant number of parts. And then Optimus goes ahead and chooses the green design point over here. And when you look at that bell, the entire range of that bell curve lies within your safe domain. And so basically what Optimus is helping you do here is it's building statistical process control and almost like a design for Six Sigma right into your model. And so you're dramatically improving the performance of your model in this case, and you're also dramatically reducing your cost. You're making sure that you know 2-3 months from now, once you release the model, you don't get recalls back because half of your widgets failed in the field. And so that's the beauty of Optimus, is from the design standpoint, you can start to build in robustness into your models. Okay, and so in this case here, we'll take a look at the final model that we had. And this is, so this was the final model that we created based on what Optimus recommended for the dimensions. And just some quick highlights. So not only did it meet our initial design specifications, but we're also able to make that part 44% lighter, which again is critical in the aerospace industry. And we also saved 75% time in this case. Okay. Now, at this point, I'll pause for a second and show you a live use case of Optimus, where we're using Optimus to control a simulation process. And I'll show you some of those features I just talked about. All right. So right now, this is Optimus. And so first off, when it comes to creating a process optimization or just a process integration workflow, with Optimus, it's very simple and easy to use. So each little icon in here has its particular function. In this case, what we're basically telling Optimus to do is to we have our dimensions, and each green bin you see in here represents some sort of file that Optimus is intended to interact with, either as an input file for one of our simulation softwares, or as an output file that it has to receive. And so one of the things we'll do here in setting this up, this part is almost fully set up. What we need to do though is this. We're also interested in getting the mass. And this Thunderbox here is what controls Creo parametric, and Creo is the one that's going to tell us the mass. And so in order to finish this setup, just to show you how easy it is to use, I'm going to do this on the fly, and I'll go ahead and create that, and then connect it together. And so we'll go ahead and connect and say that box connects there, and also like that to here. And you'll notice in all of 3 clicks, I've been able to finish off that workflow, and it intelligently understands which icon connects to the other. And now I'll go ahead and basically tell it or verify what exactly I want it to do. And in this case, we'll go here and tell Optimus, Creo will give you a file that is similar to this right here. And whenever you see this file, I want you to look for a string called mass. And the second time you see that string, I want you to extract in there the number that comes right after it. And so now Optimus is going to say, well, that's mass, this is mass. The second time I see it, I'll extract this number. And now we can verify what we just told it, and Optimus highlights and says, I understand, I'm going to extract that number as the mass value. Right? And whenever we hit OK, we can check our mass output variable, and that again reports exactly what our Creo output file told us. And so again, that just shows a very simple and easy way. In all of 10 seconds, I'm able to tell Optimus, hey, extract this number from the Creo output file because I need to see that in Optimus. And so what I'll do now is I'll flip to one here, and I'll show you a quick example of this here, where we just created a quick Optimus workflow to run, a couple of different optimizations all together. And what I'll do here is I'll tell Optimus I want to run 2 experiments together, and I'll start that. And you'll notice over here in the console, Optimus is busy doing all the heavy lifting. It says, 1 file moved. And so, in your regular everyday workflow, you will do some file copying or pasting from one folder to another. Well, Optimus is doing all of that for you intelligently on the fly. And now you'll notice in this particular case, if I highlight over here, you'll notice how Optimus has already opened 2 different Creo parametric windows, right? And now Optimus starts to control both of those Creo windows independent of each other. And now it's typing in intelligent dimension values and controlling Creo, telling it what to do in the background. And all of this without my input. Now, as this is going on, I'll go into Optimus and show you what's basically running. Whenever I started that analysis, Optimus basically started off here and generated some intelligent dimension values. Again, not just guessing or putting its finger into thin air, but based on certain parameters I defined for it. And then it plugs that into this particular setup file. Now Optimus understands this Thunderbox controls the software, controls Creo parametric in this case, and Creo needs 3 input files in order to run, and so I have all those 3 bins pointing into Creo. And when I'm done analyzing in Creo, Creo will output for me a step file, which is this green bin. And now I need this step file as an input into Elmer. Into GMesh. And so this Thunderbox here controls GMesh. And now you'll notice that Creo is no longer active. Creo has now been closed. But if we go and look at our computer processes over here, you'll notice I see 2 processes of GMesh running in the background. And so at this point, now we are working within this Thunderbox of the process workflow, where Optimus is now running that analysis inside of GMesh automatically. Now when GMesh is done, it's going to spit out 4 files in those bins that is then going to pass on into Elmer, and Elmer is going to start solving. And in this case, again, Optimus intelligently understands, Elmer needs 2 setup files that it's going to give Elmer, and resulting from that, Elmer is going to give out 2 different results files. And from those results files, in this case, Optimus knows I'm going to go into this one and pick out what the time it took to solve the model. And I'm going to go into this top results file and find the maximum stress of, that's in that model. And so you can see how, I just walked through that entire workflow, something typical that you would do every day, but now you can automate that entire workflow with Optimus. Now, by the way, when I mentioned earlier that in this particular design of the nose wheel steering arm, we saved 75% time, some of you may have thought, well, how did you do that? Because Optimus can control the programs automatically, it has a parallel workflow where you can basically tell Optimus to run processes in parallel if it needs to. And so in this case, when I told it to run 2 analyses together, Optimus knew that both of those analyses can run independent of each other, and so it started up 2 Creo windows simultaneously. It didn't have to finish one before starting the other. And so likewise, in that particular project that we did, we had access to 4 licenses of each software. And so again, another huge time-saving benefit. One engineer can sit in front of one computer and crank out 1 simulation at a time. With Optimus, with those 4 licenses, it immediately pulls out 4 instances of each software and commanding all 4 of them independent of each other. Again, dramatically improving your simulation time, where you can get 4 simulations done in the same amount of time as it will take to complete 1 simulation, serially. Now, this particular simulation is going to keep on going for about another, 7 or 8 minutes. So I'll just switch over to one where we already have the results. So we'll switch over to this for test finished here. And if we take a look at the results here, we'll notice basically what Optimus did. Optimus intelligently guessed design variables, ran all those simulations, and then came out and retrieved those design values back and said, okay, based on all of these dimensions, these are the values you have for your maximum stress and for the time it took to solve, and for your mass as well. Now, if I then wanted to go on and further query this and process this further, this is where I can begin to look at things, for example, like correlation values, where I can now begin to take a look and see, okay, well, how does my mass correlate with any particular dimension that I have, or how does my stress correlate with any particular dimension that I have. And all of this, again, in one very simple and easy to use workflow. And so that basically captures from start to finish the process integration and optimization side of Optimus. Now at this point we'll open the floor up for questions. Are there any questions or comments? Actually, I will check the questions pane right now. Yes. Okay, yeah, so we have some questions. So the first question here is someone asking, in your case, you use SolidWorks and ANSYS, and you're asking, does Inspire integrate with those? And the short answer to that is yes. Yes, Inspire integrates with over 50 different software and simulation packages, and it definitely does integrate with SolidWorks and ANSYS, and it can control those and command either geometry changes or simulations. Now, another question is how does Optimus know what to do? Okay, and that's a good question. So in this particular case, or I guess in any case when you're using Optimus, usually you would want to first off run one experiment or one simulation manually. And so I would manually open Creo and change all those dimensions. I would manually import it into GMesh and generate the mesh and then solve in Elmer. I would have to do that at least once. Now, once I do that, I'll already have all the files necessary. And now, the only additional step then is opening up Optimus and telling Optimus, hey, there's this software called Creo. These are the files you need to run Creo, and these are the dimensions you need to change. Now I'm doing that based on dimensions that I've already changed, and so Optimus has a framework to go by. I can tell it, hey, open Elmer, and you can expect to receive this kind of file as an input to Elmer, and Elmer will output another file. But again, it's going off of one simulation experiment that I've already run manually. And again, building the workflow, it really doesn't take a lot of time. It only takes, in this particular case, about 10 minutes to build a workflow. And so it doesn't take a significant amount of time out of the entire simulation experience. But when it comes to being able to run multiple simulation jobs in parallel, that just dramatically improves your productivity. Now, another the question is asked here. It says, can the units be selected for the mass also, or how does it handle units? Uh, so in this particular case here, Optimus will handle the units either based on what your simulation software outputs, or whatever you want it to read into Optimus. So in other words, if Creo is specified to output units in kilograms, then Optimus by default will read in those units in kilograms as well. Now, if for whatever reason I wanted to see the results inside of Optimus in pounds, then when I'm creating the workflow, I can tell Optimus, hey, Creo is going to send you this in kilograms, but I want you to convert this to pounds and show me the result in pounds. Now, another question in here goes on to say, is Optimus just a CAD simulation software, or does it work with other types of software? And the short answer to that is yes. It's not just a CAD simulation software. It can also work with others as well. And so with Optimus, the other thing I didn't mention is that Optimus has a Python API that's open and very easy to integrate with. And so some of the people that use Optimus, don't use it for simulation software, but they have many different computer processes that they need to control. And one needs to pass a file to another that then needs to pass something else to another, and all of those need to process in sequence. And we've had cases where customers will use the Python API and use Optimus almost like the circuit board in the background to connect all those different softwares together that don't have to be simulation softwares. It could be an order processing system where a customer goes on your website and selects configuration A of your model, and when they do that, that sets around a cascade of different commands where one software processes the variables in configuration A to see if that's going to be a viable design, and on and on and on. Optimus can be used in that kind of order processing workflow as well. And then we have another question here where it says, how long from start to finish would this particular workflow take? And this particular one would take about 12 minutes or so to run. Are there any other questions? Okay. Okay. So yeah, it looks like the questions pool is drying up here. But again, if you have any other questions, I will my contact information and Sean's contact information are both on screen right here, and so you can email me any questions you have about Optimus, what its capabilities, what you can use it for, and I'll be glad to answer any questions you have. We have reached the end of the webinar. Thank you so much for watching, and we hope it was very beneficial and informative to you. And again, stay tuned for next week when we come back with another edition of our Boundary Webinar Wednesdays. Thank you.